Good morning, dear students. Welcome again. Today I am going to start my second last topic of our chemical kinetics chapter, that is Arrhenius equation. According to general concept, we know that when temperature increases, rate of reaction increases. Why? Because when temperature increases, our kinetic energy increases. If kinetic energy increases, it means velocity of particle increases. Velocity of particle increases, it means number of collision increases. Hence, effective number of collision increases. That's why rate of reaction increases. Generally, 10 degree rise in temperature, our rate of reaction become double to triple from its initial rate. But according to Arrhenius, with the help of mathematical expression, we can also prove how the rate of reaction vary with the variation of temperature. According to him, K is equal to A e to the power minus A by RT, where K is equal to rate constant, A is equal to Arrhenius constant, or you can say pre-exponential factor or frequency factor. All are become similar. EA is equal to activation energy, R is equal to gas constant, T is equal to absolute temperature. Means temperature always considered in Kelvin. Suppose this is our equation first. From equation first, it is clear when T increases, it means overall such term decreases. If such term decreases, it means what? K increases. And we know that dx upon dt is directly proportional to what? K. That is, rate of reaction is directly proportional to rate constant. That's why rate of reaction increases with variation of temperature. So we can write K increases with increase in temperature. If T tends to infinity, therefore K is equal to what? A. Because this upon 0, e to the power 0, 1, it means K is equal to what? A. Or we can write K upon A is equal to what? E to the power minus A by RT. That is, fraction of molecules fractions of molecules having energy greater than equal to activation energy. So K is equal to A. K is equal to A become only possible when T tends to consider infinity. According to the concept of physics, e to the power minus A by RT is also known as Boltzmann factor. Is equal to what? Boltzmann factor. With the variation of temperature, our K vary. Suppose at T1 temperature, our rate constant is K1. For the same reaction, if temperature is T2, then rate constant become what? K2. So with the variation of temperature, a new relation can develop with the help of our Arrhenius equation. If we take log base E both the sides in our equation first, we get what? ln K ln A minus EA by RT. Because log E base E into E is equal to what? 1. If we convert ln K in terms of base 10 multiplied by 2.303 into log base 10K is equal to 2.303 into log base 10A minus EA by RT. Dividing both the side by 2.303. We get what? Log base 10K log base 10A minus EA by 2.303 into R into T. Suppose this is our equation second. In this equation, log base 10K is equal to Y. This is said to be what? Mx. This one becomes C. So, the numerical value of slope is equal to what? Minus EA by 2.303 into R. If we draw the graph between log base 10K versus 1 by T, then a straight line become obtained. This is a straight line for negative slope, and the numerical value of slope is equal to what? Minus EA by 2.303 into R, where R is equal to gas constant. and this is expression for linear equation because satisfied the equation y is equal to mx plus c. Activation energy can determine with the help of rate constant at two different temperatures. That is, we can write EA of reaction can be determined by measuring rate constant at two different temperatures. That is, at temperature T1, our Arrhenius equation become log base 10 K1 log base 10 A minus A by 2.303 R T1. A and activation energy are constant with the variation of T, rate constant vary. At temperature T2, we can write log base 10 K2 log base 10 A minus A upon 2.303 R T2. Suppose this is equation third and this become 4. If we do 4 minus third, we get what? Log base 10 K2 minus log base 10 K1. Log base 10 A, log base 10 A cancel. This minus this means what? A by 2.303 R T1 minus A by 2.303 R T2. A upon 2.303 R common. That's why we can write what? Log base 10 K2 by K1 because this is log A minus log B. If we take common, A by 2.303 into R. This give what? 1 by T1 minus 1 by T2. If we solve, we get what? Log base 10 K2 upon K1 is equal to A upon 2.303 into R. We can write what? T2 minus T1, T1 into T2. This is a new form of Arrhenius equation. So we can write what? Log base 10 K2 upon K1 is equal to activation energy divided by 2.303 into R T2 minus T1 T1 into T2. This is final equation 5th. From this equation, if activation energy is equal to 0, it means what? Whole term is equal to 0. 0 means what? log base 10 1. So K1 must be equal to what? K2. From equation 5, this is equation 5. If EA is equal to 0, then K1 is equal to what? K2. Practically not possible. Second one, the minimum energy which must be possessed by reacting molecules for a reaction become occur known as threshold energy. Threshold energy means total energy possessed by the molecule. C. The minimum extra amount of energy required by reactant molecules for converting into product called activation energy. Activation energy means what? Threshold energy minus energy possessed by the molecule. That is activation energy is equal to threshold energy minus energy possessed by molecules. So finally we can say what? Threshold energy is always greater than activation energy. Lower the activation energy, rate of reaction become what? Faster. Higher the activation energy, it means our rate of reaction become slower. With the help of graphical representation, we can clearly understand the concept of threshold energy and activation energy. So my next topic is graph between energy versus progress of reaction. First, for exothermic reaction, suppose if we consider here energy, that is potential energy in x-axis, if we consider progress of reaction. Suppose the energy of reactant, that is supposed to be ER. Here reactant converted into product, this energy is said to be EP, energy of product. Here this is said to be what? Activated complex. This energy level is said to be ET, total energy, known as what? Threshold energy. This level is said to be what? EAF, active energy, that is activation energy for forward reaction. Here we consider EAB, activation energy, that is energy for backward reaction. So energy backward is always greater than activation energy of forward reaction. So delta H is equal to what? EA forward minus EA backward. That is, always give negative value. If delta is negative, then our reaction become what? Exothermic in nature. This graph indicate if we find out that part of energy, it means what? Total energy minus energy possessed by the molecule. The rest part is said to be what? Activation energy for forward reaction. And the activation energy of backward is always greater compared to activation energy of forward reaction for exothermic reaction. Similarly, for endothermic reactions, again, if we do the graph between energy, suppose this is the energy of reactant when reactant converted into product. This is said to be energy of product. This point indicate ET threshold energy, known as what? Activated complex. This part is known as activation energy forward, and this part is known as activation energy backward. Here The activation energy of forward reaction is greater than activation energy for backward reaction. That is, here we write progress of reaction. So delta H EA forward minus EA backward always give positive value. Positive value means our reaction become endothermic. If we find out the activation T for forward, it means what? Total energy minus energy possessed by the molecule, again said to be what? Activation T for forward reaction. So such are the concept of activation energy and threshold energy. Threshold energy is also known as total energy. Our last theory for this lesson is Collison theory. That is Collison theory of chemical reaction. According to this theory, reactant molecule must possesses minimum energy and proper orientation. If orientation of molecules which collide each other are proper in nature, then reacting molecule converted into product. So we can write what? According to this theory, for a reaction to occur, there must be collision in between reacting molecules. Total number of collision per second per unit volume is called collision frequency. Generally, this frequency is represented by Z. Z is called what? Collision frequency. Generally, its value is very high for gaseous reactions, but only a small fraction of these collision are capable to convert reactant into product. These collision are called effective collision. Conditions for effective collisions. The first condition is reacting molecules possesses minimum amount of energy. And the second one, proper orientation of collision. Proper orientation of collisions. If such conditions satisfied, then our reactant converted into products. Our orientation is proper or improper in nature, which can understand with the help of following organic reaction. That is, suppose if we consider CH3Br plus OH minus gives CH3OH methyl alcohol plus Br minus. CH3Br is said to be substrate. OH is called what? Attacking reagent. OH attack either from rear side or front side. So if we write in the structural formula of methyl bromide, positive and negative, if OH minus negative attack, then two possibilities arises. First, OH attack from rear side. This type of orientation is called what? Proper. If OH attack from front side, then repulsion occur between two negative. Therefore, no product become formed. This type of orientation is called what? Improper orientation. So if orientation is proper in nature, then methyl alcohol become obtained. But when orientation is improper, then no product become obtained. Okay, so we have completed our lesson. Try to solve problems which are already given in your assignment. Thank you.